Welcome to September 24th LeetCode Challenge, nth Tribonacci number. The Tribonacci sequence t at n is defined as the following. You have t at 0 being 0 equals 0, t at 1 equals 1, t at 2 equals 1, t at n plus 3 is equal to t at n plus t at n minus 1 plus t at n plus 2. For any sequence n greater or equal to 0, given n, return the value of t at n. So we see that we already have a sequence here, and the sequence in kind of Tribonacci / Fibonacci type of questions really involve, I guess, combinatorics, and where you really want to add things in the order sequence that they're given in. So I'll give you an example 1, you have n equals 4, right? And you want to fulfill this perspective here. So we see that t at 0 will be 0, t at 1 be 1, t at 2 be 2, and then you keep on adding up this sequence, right? So we know that, for instance, if t at 3 is equal to 0 plus, so if you move one forward and you say n equals 0, and then you basically add 0 plus 1 plus 1, you get 2, right? And then you move up this. So we know t at 3 now, and now we need to know t at 4. T at 4 is basically, t at 4 will be, let's see, t at 1 plus t at 2 plus t at 3. And then, well, t at 1 is 1, t at 2 is 2, t at 3 is 2, therefore you get 4. And then you come on adding up to n equals 25, right? And you get this large number. N is between the bounds of 0 and 37. Guaranteed to fit a 32-bit integer answer. Alright, so let's look at some hints here. Make an array f and length 32, and then set it. Oh, so this is basically calculating all of the answer all the way up to 38 in the and then you just basically always have the answer because it's calculated, right? It's possible to get all the answers. F at 0, then make an array basically for each answer between 0, f at 0 to all the way to f at 37, right? That's a way. I mean, that'll be pretty much making the entire answer ahead of times. Now write a loop. Let's actually probably do that. Let's do that. It's basically using kind of coming back from the dynamic programming type of approach, but essentially it's combinatorics using dynamic programming. So the idea is to use the dynamic program where you have each element at I being the number, then we just find the next answer to it using this this rule here, the sequence. Moreover, we don't need to really do additional memory because we can keep the last 3 numbers. So as long as we know all 3 digits, we just add to the next one. Then pretty much that's it. That was a lot of talking, but let's go. So let's go with A, B, C being the first 3 letters of that. So we have 1, 2, 3. Ideally, I could use T sub the letter, but I don't want to. So this is the base case. So the first 3 letters of you know what? Let's just T1. No wait, T0. T1, T, oh, what am I doing? T2. Base case for each cell or range in range of n. What we want to do is return, copy this. We want to update it basically to t at 1, t at 2, and then we want C to be t at 1 plus t1 plus t0 plus t1 plus t2. And then we're just gonna, have insert on. continue this pattern. And then do the for loop, then return t2, which is the last number. Let's run this. It's pretty straightforward, I think. Right. So time complexity is big O of n because we have a for loop here, which loops through each value integer in which each value in the array. As to be expected. Space complexity is big O of constant space because we just store everything in the last number, so it's a value. All right, have a great day, guys.